up to that point 2, the minimum value occurs at the left hand point till that point 2, and if you move further between 0 and 10, okay, we don't know exactly what point, but definitely there will be an intersection because it is a polynomial expression, it is a continuous function value. So at this point the perimeter is maximum, but what we want is the area at this point. We found r is the distance. We want this distance to be minimum. We want the closest point, that means the distance if f of x equal to 2x cube minus 9x square plus 12x plus 2 and g of x equal to maximum of f of t where t belongs to the interval 0, x and h of x equal to minimum of f of t where t belongs to the interval x to infinity, then the number of points where f of x plus g of x is not differentiable is. Here a function f of x is given which is a cubic expression in x. Now g of x and h of x are given in terms of f of x. See, g of x is the maximum value of f of x from 0 to x. Similarly, h of x is the minimum value of f of x from x to infinity. So this is a variable value. Maximum is not a constant value because the interval itself is a variable. So 0 to x, x is not a constant. So from 0 to x, whichever is the maximum value, so that is the value of g of x. Similarly, from x to infinity, whichever is the minimum value of f of x, that is the value of h of x. So f of x is to be found, right? You have to draw the function f of x, g of x and h of x, so then we can find the number of points where the function is not differentiable. F of x plus g of x is not differentiable. So let us find separately where the function g of x is not differentiable. For that we have to draw the curve. Okay, so what is given? So the function f of x is given. F of x is given to be, so this function 2x cube minus 9x square plus 12x plus 2. So this is the function f of x. First of all, we have to draw this function f of x. Okay, let us draw this. So for that, let us find the derivative to get an idea. So f dash x is equal to, so that is 6x square minus 18x plus 12. So if you take this 6 out, so this will become x square minus 3x plus 2. So we can factorize it. So x multiplied by x minus 1, x minus 2. So this is the function derivative of the given function f of x. Alright, so the derivative has a root 1 and 2. Okay, that means the function f of x attains a maximum or minimum value at the point 1 or 2. Okay, so roughly we can draw the curve like this. So at the point 2 it attains minimum value, at the point 1 it attains maximum value. So the function is drawn like this. Okay, so it may be up or down, that doesn't matter. So we only need the shape of the curve, right? At the point 2 it attains minimum value, at the point 1 it attains the maximum value. Okay, so we have roughly drawn the curve. Now we have to draw the function g of x. So what is g of x? So g of x is the maximum value of, say, f of t where t belongs to the interval 0 to x. So that means between 0 and x, so x is a variable, so between 0 and x you find the values of f of x. So among that the maximum value is taken as the value of g of x. Alright, so let us take this example. Now we'll start from 0. Okay, so we will move along x-axis in the positive direction. So let's move in this direction. Okay, for example, this is the value of x. Now in that interval, what is the maximum value of f of x? So that is the value of g of x. Okay, what is the maximum value? This maximum occurs at the point x itself, because it is an increasing function up to that point, up to the maximum point. Okay, up to the maximum value. So it is an increasing function. That means at the right end point you will have the maximum value, which means g of x is same as f of x only. Up to what point? Up to the maximum point. That means 1 here. Up to 1. So the maximum value of f of x is the value at the right end point x. So that means it is the function f of x only. F of x and g of x both are same. I am not writing the function g of x. From the graph we can understand. So it is increasing. So as long as it is increasing, at the right end point you will have the maximum value, and that is the value of g of x. Okay, done. So that means up to that point 1. Now if you move a little further and it comes down, so now the maximum value is not at the right end point, because it is coming down. So the maximum value is at the point 1 only. Even if you move further, the maximum value is at the point 1 only. Do you understand? So you move further. Okay, now the maximum value is only at the point 1. Okay, till what point? So the same line meets the curve again at some other point. Up to that point the maximum value is the same value as the value of the function at the point 1, which means it is like a constant function. You understand? It is a constant function. Now if you increase the value of x, now the maximum value increases. So that is at the right endpoint. So that means the graph of the function g of x looks like this. First, it is same as f of x. G of x is same as f of x up to the point 1 because it increases. So at the right endpoint it is the maximum value. At x only we have the value, the maximum. That means fx, gx both are same up to the point 1. Now from 1 to that value, we don't know what that value is, it doesn't matter. So up to that value, okay, so the maximum value is the value at 1 only. It is a constant value. So you move the value of x from that point 1 to that point. The maximum value is a constant value which is f of 1. Do you understand? Yes. Now again, if you increase the value, the maximum value happens at the right end point. So this is roughly the graph of the function g of x. Okay, done. Okay, now from this graph we can understand that this is not differentiable at which point. So this function is not differentiable at only one point, right? That right end point. Okay, so that point is the only one point where the function is not differentiable. So we know that from the graph. So the curve is not smooth. Okay, when the curve is smooth, it is a differentiable function. So there is a sharp corner, right? So that sharp edge, so that means so it is not differentiable at that point only. Okay, so at one point the function is not differentiable. Okay, done. So we're done with the function g of x. Okay, we've drawn it. Now we will draw h of x. So h of x is the minimum value of the function. So minimum value of f of t where t is from x to infinity. That means x is the left end point now. Now we have to start from infinity. Okay, we will move from infinity to that point. Now from infinity to that point, suppose the value of x is there. Okay, so that means what is the minimum value? The minimum value occurs at x only because it is a increasing function again. So increasing function in the right end points, right? So increasing function. So that means in that interval from x to infinity, the minimum value occurs at the point x only. But up to what point? Up to that point 2, because 2 is the point where the function is minimum, which means if you move from the right end point, which means positive infinity to x to 2, okay, up to that point the minimum value occurs at the left end point only. Okay, now if you move to the left of this point 2, that means the minimum value is no more the left end point, right? At x it is not the minimum value, at x it is not the minimum value. So here the minimum value is at 2. So up to what point? From 2 to, so this left end point. Okay, so here, so along this line it is a constant value. Okay, so just like the previous case where the maximum value is constant from one interval, okay, from 1 to that point, similarly here the minimum value is constant from that point 2 to this one point. So we don't know what that point is, it is not required. So it is a constant value. Now if you move to the left further, so in that case the minimum value is again left end point. Do you understand? So this is the graph of the function. Okay, do you understand? Up to from the right end point up to that point 2, the minimum value occurs at the left end point till that point 2, and if you move further, so the minimum value remains constant. So the 2, f of 2 is the minimum value. Okay, again up to this point only. After to the left of this point, again the minimum value occurs at the left end point. So that means this is roughly the graph of the given function. Okay, we have drawn h of x. Do you understand? So h of x is also drawn. Now tell me at how many points h of x is not differentiable? Yes. So same thing again. So there is only one sharp corner, right? So the function is not differentiable at this point. Now g of x plus h of x. Okay, this sum is not differentiable at how many points? See, we know that the g of x is not differentiable at one point. Okay, so that value, we don't know what that value exactly is, it is not required, but at one point it is not differentiable. Similarly, h of x is not differentiable at one point. Now if you add these two, g of x plus h of x is not differentiable at these 2 points. That means so g of x plus h of x is not differentiable at 2 points. That's all. So that is the answer. Do you understand? Yeah.
But the sum of two non-differentiable functions may be differentiable.
See, g of x and h of x are not differentiable. This particular function is not differentiable at that point. Okay, right end point. Okay, say for example some value alpha, and this h of x is not differentiable at some point, say beta. So this g of x plus h of x is not differentiable at both alpha and beta, right? Because see, if g of x is not differentiable at some point, h of x is not differentiable at the same point, then this sum may be differentiable also. Do you understand? But g of x is not differentiable at some point, but h of x is not differentiable at a different point. That means the sum is not differentiable at both the points. Do you understand? That is why, so g of x plus h of x is not differentiable at these 2 points. Do you understand? If both the functions are not differentiable at the same point, then we can't say that the sum is not differentiable at that point, right? The sum may be differentiable in that case. But here, So this sum is not differentiable as these two separately are not differentiable at two different points. So that means, so this is the answer. So this function is not differentiable at two different points. Okay. Which of the following inequalities is correct? Here we have to compare two values, 3 tan inverse 2 and 2 tan inverse 3. So among these two values, whichever is bigger, smaller, so that we have to find. Okay, so let us find it. So now for convenience, so we will take the function f of x to be, so tan inverse x divided by x, because the given expression is actually of this form only. So we have to compare tan inverse 2 divided by 2 and tan inverse 3 divided by 3. So generally we take the function tan inverse x divided by x. Alright, now we have to check whether this is an increasing function. So increasing function means one inequality will be satisfied, decreasing function the reverse inequality. So we only have to check whether this function is increasing or decreasing. That's all. Okay, simply let us find the derivative. So f dash of x, so that equals, alright, so quotient rule, so x squared, so x multiplied by tan inverse x derivative 1 by 1 plus x squared minus, so tan inverse x. Okay, so that's all. So if you simplify this, so this is x minus 1 plus x squared tan inverse x divided by, so this x squared multiplied by 1 plus x squared. So this is the function f dash of x. Now for an increasing function, this value must be positive. Is it positive always? But we don't know for sure whether this value x is bigger than this value or smaller than that value. So we don't know whether this expression is positive or negative. Denominator is always positive, so not a problem. But the numerator, is it always positive? So we don't know. So let us consider only the numerator as another function, say g of x. Now we want to check whether this g of x is positive or negative. You understand? Only the numerator, not taking the denominator, because if you take the entire function, so finding the derivative will be more complicated, because this is again quotient rule. But only the numerator is the problem, because denominator is anyway positive. So consider only the numerator as our new function x minus 1 plus x squared multiplied by tan inverse x. Okay, so this function is positive or not? Let us check. So g dash of x, the derivative. So this is 1 minus of, so 1 plus x squared multiplied by the derivative of tan inverse of x, which is again 1 by 1 plus x squared, again minus, so tan inverse of x multiplied by the derivative of this, so 2x tan inverse of x. Now, so this is 1 plus x squared, 1 plus x squared cancel, this is 1 minus 1. Okay, so that is 0. So minus of 2x tan inverse x. So minus 2x tan inverse x. We only need positive values of x, no negative values. So for positive values of x, so this x tan inverse of x is always positive. So this value is negative then. Do you understand? So g dash of x is negative. So the derivative of g of x is negative. That means it is a decreasing function. So g of x is a decreasing function. So g of x is a decreasing function. Okay, so that means for a value of x greater than 0, okay, decreasing function. So for a value of x greater than 0, so g of x will be smaller than g of 0. Right, the inequality reverses for a decreasing function. So g of x must be smaller than g of 0. What is g of x? So this value. Okay, so this function. Now that is less than g of 0. But what is g of 0? 0 multiplied minus 0. So 0 is the value of g of 0, which means g of x is less than 0. When g of x is less than 0, this whole expression is negative. So when this expression is negative, f dash of x is also negative, because denominator is positive, numerator we have taken separately, and we proved that, and that value is negative. So that implies f dash of x is also negative. So f dash of x is also negative. So that implies f of x is a decreasing function. You understand? So f of x is a decreasing function. So when f of x is a decreasing function, again reverse inequality. So we know that, so 2 is less than 3. When 2 is less than 3, f of 2 must be greater than f of 3, because it is a decreasing function, inequality reverses. But what is f of 2? So tan inverse of 2 divided by 2, so that is greater than tan inverse of 3 divided by 3. So that's also, that is our answer. So 3 tan inverse 2 is greater than 2 tan inverse 3. You understand? So that is our required answer. We use simply the concept of increasing decreasing function, but we are not able to prove directly whether f dash of x is positive or not. okay, because this expression, it's not very clear whether it is positive or not. So you consider this separately and prove that this expression is positive. From that we understand that f dash of x is also positive. That means f is increasing, negative, so that means f is decreasing. So using that we got this conclusion, okay. The function f of x equal to x minus 1 to the power m multiplied by x minus 2 to the power n has a local maximum, a local minimum and a point of inflection. Then the value of m plus n plus mn can be. So the function given here has a maximum value, a minimum value and a point of inflection. Now we have to see what are the possible values of this m and n, right? So the function given here is fx, so that equals x minus 1 to the power m multiplied by x minus 2 to the power n. So to find the maximum or minimum, you have to find the derivative. So find the derivative and equate that to 0. So we have to use the product rule. So m multiplied by x minus 1 to the power m minus 1, x minus 2 to the power n, plus, so this derivative now. So x minus 1 to the power m n, x minus 2 to the power n minus 1. Okay, yes, now we have to equate this derivative to 0. So we take out the common factors. So x minus 1 to the power m minus 1, and similarly you take out x minus 2 to the power n minus 1. So we'll get, so m multiplied by x minus 2, m times x minus 2, and plus n times x minus 1. Okay, so this should be equated to 0 to find the point at which the function can be maximum or minimum. So that is x minus 1 to the power m minus 1 and x minus 2 to the power n minus 1. So this will become m plus n times x minus of, okay, 2m plus n. So this should be equated to 0. So then we get the value of x. So these are the values of x. We are getting 1, 2 and 2. Then here the value of x is 2m plus n divided by m plus n. So these are the three values we have got. Now at these 3 points, this function should be, at one of the points it should be maximum, and at one point it is minimum, and at one point it has a point of inflection. Alright, so let us find it. So let us plot these points here, right? Yes. So 1 here, 2 here, and also here we have the point 2m plus n divided by m plus n. Alright, so we've got 3 points, right?
Is 2m plus n by m plus n greater than 2?
Not necessarily. This value may be less than 1 or less than 2 or greater than 1. So it doesn't matter to our question. So this is just one of the values. Actually this value lies between 1 and 2, right? Because we can write this value as, so 2m plus n can be written as m plus n divided by m plus n. So that means it is 1 plus m divided by m plus n. So this value is 1 plus something, so that means it is greater than 1 but less than 2, because this value is less than 1 because it is denominator is bigger. So this value is less than 2. So that means, so this lies between 1 and 2. So that means somewhere here, but that doesn't matter, right? So to our question, so it is just one of the values. Okay, so I'm marking it here. Okay, now there are 3 points. At one of the points it attains minimum, maximum, and the other point it is point of inflection. Now how will you know at which point it is maximum or minimum? Suppose let us take this point. At this point, so can it have point of inflection? So what is meant by point of inflection? The derivative is 0 at that point, alright, but the second derivative, the derivative does not change the sign. So which means you take a value which is less than this and greater than this, the value does not change. The sign of that expression does not change, right? So now, but if you take this value, if you take this value, if you take a value which is little less than this, and that will have one sign, suppose it is negative, and take a value which is more than that, it will be positive, right? So that means this definitely changes sign. So that means this is not the point of inflection. Maybe at this point it is a minimum value. Okay, so suppose it is a minimum value. Okay, so minimum value at this point. Okay, minimum, not point of inflection. That means it will increase after the here. Okay, yes. Now at one of these points it attains the maximum value, and at one of the points it is the point of inflection. Okay, yes, at which point it is a point of inflection, so we don't know. Suppose it is point of inflection at this point. Okay, at this point, so that means it is not the maximum value. The curve does not come down, right? It will increase like this, which means the derivative does not change the sign. So the derivative is negative to the left of 2, and the derivative is also negative, to the right of 2 also the derivative does not change sign. Unlike here, see, to the left of this point the derivative is negative, and on the right the derivative is positive, so negative to positive, so that is why it is minimum. But here point of inflection, so derivative does not change the sign, so negative here, so at both the end points, right, both the sides. Now here, that means at 1 it has to attain the maximum value. Do you understand? So at 1 it is the maximum value, at 2 it is the minimum, sorry, the point of inflection, and at this point it has the minimum value. Okay, now it may be the other way around, maybe at 2 it is the maximum value, at 1 it may be the point of inflection. Now tell me, when will it happen? So at 1 it has to attain the maximum value, which means it has to change the sign from positive to negative. So when will that happen? So when x is less than 1 it has to have one sign, and when x is greater than 1 it will take the other sign. So for example, when x is less than 1 it is negative. Okay, so if you take a value which is less than 1, it has to be negative. So for this value to be negative, this power m minus 1 must be an odd power, right? So even, suppose it is even power, so if this value is even, then whatever this value is, it will always take the same sign. Do you understand? So the condition is that m minus 1 must be an odd number, okay, not an even number. All right, so m minus 1 must be a odd number. That means m is an even number. Do you understand? So if m minus 1 is an even number, so it does not change the sign, so that means it will become point of inflection. So now here take the point at 2, so less than 2, greater than 1, it should have the same sign. So that will happen only when this power is an even number. Alright, the power is even number, less than 2 or greater than 2, so there is no change in the sign, so that means n minus 1, so that must be an even number, that means n is a odd number. So that's all, m is even number, n is odd number. So do you understand? So that is the conclusion. So that's all. So one of them is even number, the other one is odd number. Maybe m is odd number, n is even number, that is also possible, because at the point 2 it may be maximum, at 1 it may be point of inflection. So one of these numbers is odd, the other one is even. So now tell me, what can be the possible value of this one? M plus n plus mn. So now we will see what are the possible values this expression can take, right? M plus n plus mn, right? Here m is an even number, n is an odd number, or the other way around, right? One of them is even, the other one is odd. So this sum must be an odd number, and this is an even number, the product of even and odd. So that is an even number, even plus odd number is an odd number. So the whole expression must be an odd number. So that means, so this cannot be an even number, so we can reject the options which contain even numbers, right? So m plus n plus mn, right? Let us look at the other options. But so let us simplify this. See, it can be factorized actually. You can write it as m plus 1 multiplied by n plus 1 minus 1. Do you understand? So this product mn plus m plus n plus 1 minus 1. So this is written like this, right, for convenience. Now can this value be equal to say 39? Alright, so let us take this value to be 39. Let's see if it is possible. So that means m plus 1 multiplied by n plus 1 equals say 40. So this product is 40, alright, yes, but one of them is even, the other one is odd number, so but the product is 40. Is it possible? Is there any possibility? One is even, the other one is odd, but the product is 40. Okay, yeah, 5 multiplied by 8, right, so that is 40. So 5 multiplied by 8, so that is 40. So it is possible. So that means, so one of the 8 multiplied by 5, whatever way, so one of them is even, the other one is odd, so that means this value can be equal to 39. Okay, done. Now is it possible that this value is equal to 13? If this value is 13 or 13 plus 1, alright, so this one is added, so 13 plus 1, so 14. So can this value be equal to 14? So 14 means the only possibility is that 2 multiplied by 7. So if m plus 1 is 2 and n plus 1 is 7, so that is possible, right? So one of them is even, the other one is odd, so this is the only possibility. Okay, so that means what is the value of n here? Or you take n plus 1 as 2 and m plus 1 as 7, so any one of them. So that means we'll get the value of n to be 1 and we get the value of m to be 6. So n is an odd number and m is an even number, so that is also possible. But the problem is n should not be equal to 1, that is given in the question, right? N is not equal to 1, so but we are getting the value of n to be 1, so this is rejected, so not possible. So the only possibility is that, so this value must be equal to 39. So that is the only possible value of this expression m plus n plus mn, right? So that is the answer to the question. Consider the rectangle lying in the region x comma y belonging to r cross r, x lying between 0 and pi by 2, y lying between 0 and 2 sine 2x, and having one side on the x-axis. The area of the rectangle which has the maximum perimeter among all such rectangles is. Here the range of values of x is given 0 to pi by 2. Similarly, y lies between 0 and 2 sine 2x. So this is a curve. So now we have a rectangle inside this, two of whose vertices lie on x-axis and two vertices lie on this curve. We want the perimeter of this rectangle to be maximum. We want the area of this rectangle whose perimeter is maximum. Alright, so let us find the perimeter. So that is sum of all the four sides. Okay, let us first find the base. Now the total distance is pi by 2. Let us take this distance to be x, the vertex from origin. So that distance is taken as x. Now then the other vertex is at a distance same x from pi by 2 because by symmetry, so x. So that means what is the total base length? So that is pi by 2 minus 2x, right? So that is the length of one of the sides of the rectangle. So let us find the perimeter. So let's call it p. So that is, so the base length, so that is pi by 2 minus 2x. So this should be multiplied by 2, right? So top and bottom, so they have the same length. Okay, similarly the height. Okay, so that is the y coordinate because that point, one vertex lies on the curve. So that means the height is same as the y coordinate, which is 2 sine 2x plus 2 sine 2x, and that should also be multiplied by 2 because both these sides are of same length. Okay, so this is our required function, the perimeter, but we want its a maximum value. So to find maximum value, so the usual method, we have to find the derivative equated to 0. So let us find the derivative. So dp divided by dx, so that equals, so that is 0, so this is minus 4, so that derivative is 4 sine 2x, so that is 8 cos 2x. So this should be equated to 0. So we get cos 2x equals, so 1 by 2. So that's all. So that will give you 2x value. So cos 2x is 1 by 2. So that value is pi by 3. So we've got x pi by 6. So that is the point at which this function is maximum, right? Not minimum, maximum. You have to find the second derivative to check if it is minimum or maximum. So what is the second derivative? Minus 16 sine 2x. So that value is negative, right, at this point. So that means this has to be the point of maximum value. So at this point, the perimeter is maximum. But what we want is the area at this point, right? Let's find the area. So area equal to the product of sides. So what is the side here? So that is pi by 2 minus 2x, so that is one side multiplied by, so the other side is 2 sine 2x. But we've got the value of x already, so x is pi by 6, so that you substitute here. So this value is pi by 2 minus pi by 3, so that is pi by 6 multiplied by, so this is 2 sine 2x, so x is pi by 6, so sine pi by 3, so that is root 3 by 2, so this is root 3 then. So that value is, okay, so we can write this 6 as 2 multiplied by 3, so that is pi by 2 root 3. So that's all. So this is our required area. So the area for which the perimeter is maximum, so that is pi divided by 2 root 3. Okay. The point on the curve 9y squared plus 4x squared equal to x squared y squared closest to origin is. Here we are given a curve, we have to find the point on the curve which is closest to origin. Suppose this is the curve, we have to find the point on the curve which is closest to origin. Usually for questions of this type, we will take the point to be x comma y, where y is written in terms of x or x is written in terms of y. We have to get the point in terms of just one variable. So it is very difficult to deal with two variables, so we have to get either x in terms of y or y in terms of x. But that is not possible here. It is a complicated expression. Getting y in terms of x, that is very difficult, so we'll have to do by a different method. So let us take this to be the closest point, and that distance, right, the closest distance, right, the shortest distance from origin, so that is taken as, say, r. Okay, r is the distance, and this line of shortest distance makes some angle theta with the x-axis. Okay, now we can complete this right angle triangle, so that means we can get this x in terms of r and theta. It's a right angle triangle, so cos theta is x divided by r, so that means we got the value of x then. So x equals r cos theta. Alright, similarly, so that height, right, the y value, y can be written in terms of theta again, so y equals r sin theta. So you got x and y in terms of r and theta. Okay.
It looks like the parametric equation of a circle.
No, it is not a circle. See, r is not a constant. If r is a constant, this is the parametric equation of a circle with center, origin and radius r. But r here is not a constant, it is a variable. See, you take a different point, there the value of r will be different. So r is a variable and so is theta. Theta is also a variable, not a constant. See, if r is constant, it is a circle with center, origin and radius r. If theta is constant, so that will be a straight line, right? Theta is constant, that means slope is constant, it is a straight line. So but here neither r nor theta is a constant, both are variables. That means this is not a parametric equation of any curve, it is simply a point in the plane. That's all. Any point in the plane can be written in this form for some value of r and some value of theta. So this is any point in the plane, but we want this point to be on the curve. Alright, we assume that this point is on the curve, so that means it will satisfy that equation. So let us substitute. Okay, so the equation of the curve is given to be, okay, so 9y squared plus 4x squared equals, say, x squared y squared. This is the equation of the curve, but this point lies on the curve, so it will satisfy that equation. So 9r squared, see, r squared y squared, so that is sine square theta plus 4r squared cos square theta equals x squared y squared. Alright, so that means r squared r squared. So r to the power 4 cos square theta sine square theta. Okay, so this is the relation. Now we can divide by this r squared, so that will give you, so this r square gets cancelled, so we'll get the value of r squared from this. So what is the value of r squared? This r squared. Now divide by cos square theta sine square theta, so that will become, one sine square theta gets cancelled, so 1 divided by cos square theta, so that will be 9 secant square theta. Alright, 9 secant square theta after dividing by the right hand side. Now similarly this will be 4 cos square theta divided by cos square theta sine square theta, so that is 1 divided by sine square theta, which is cosecant square theta. Okay. So this is the value of r. You can take value of r, so taking the square root. Okay, so now we found r is the distance. We want this distance to be minimum. We want the closest point, that means the distance is to be minimum. For that we have to find the derivative of this equated to 0, and that is the method to find the minimum value. You understand? So dr divided by d theta, so that should be minimum. You understand? So find the derivative equated to 0. But we will not do the derivative method. We use our basic idea for some trigonometry and some other method to find the minimum value of this. You can also use the derivative method. You can find the derivative equated to 0. But I am not doing that because, so we will try some other method. Okay, yes. Now this is r squared. You can write this secant square theta in terms of tan, right? So secant square theta can be written as tan square theta plus 1. So this is 9 tan square theta plus 1, so 1 times 9, so that is 9, and 4, this is cot square theta, so 4 cot square theta, again plus 1, which means 4 plus 9, so that is 13. You understand? You write this secant square theta in terms of tan square theta, similarly the other one. Okay, done. So this expression we want to find the minimum value of. Okay, now instead of using the derivative method, we use this method, arithmetic mean, geometric mean. Arithmetic mean is greater than equal to geometric mean, because you see tan and cot, they are reciprocals of each other, so this AM GM will work. What is AM GM method? Remember, see, a plus b divided by 2, that is the arithmetic mean, that is greater than equal to geometric mean root AB. That means a plus b is greater than equal to 2 root AB. You understand? For positive values of a and b, but here these values are positive only, right? Squared, so tan squared and similarly cot squared. So for positive value, so this is like a plus b is greater than equal to 2 root AB. So the whole expression is greater than equal to 2 square root of AB. So AB is 9 multiplied by 4, tan squared multiplied by cot squared, that will become 1. So plus 13. So that means, so this value is greater than equal to, so this is 36, 6 times 2, so that is 12 plus 13, so 25. 25 is the value of r squared, which means r is greater than equal to 5. So that means what? The minimum value of r is 5. So 5 is the closest, the shortest distance. Do you understand? So 5 is the shortest distance. But we want that point, the closest point. We want to find the point which is at a distance 5. Okay, how to find the point? This is the point, right? R cos theta, r sin theta. R value is found 5. Minimum distance is 5. So r is 5. Okay, done. But cos theta, sin theta, we don't know the value of theta. So how to find the value of theta? See, the minimum occurs the minimum occurs when the arithmetic mean is equal to geometric mean, right? When r is equal to 5, that is the minimum value. So the minimum is when arithmetic mean is equal to geometric mean. So that means, so equate arithmetic mean to geometric mean. That implies both the values are equal, a and b are equal. So if a and b, the values are equal, so that means arithmetic mean and geometric mean are equal. So what is a here? 9 tan square theta, and b is 4 cot square theta. They are equal. So that means 9 tan square theta plus 4 cot square theta, equal to 4 cot square. These two values are equal. Now we can find the value of tan theta from this, right? So tan to the power 4, right? Because cot square theta can be written as 1 divided by tan square theta. So tan to the power 4 equals 4 divided by 9. So we can write the value of tan theta to be root 2 divided by root 3. So that is the value of tan theta. You understand? So I'm only taking the positive values because all the options are given in the first quadrant only. So the points are in first quadrant. Let me take only the positive value. So tan theta is root 2 divided by root 3. Okay, now we found tan theta, but we want the point, okay, which is in terms of cos theta and sin theta. We've got tan theta, but we want to get cos theta and sin theta. R value is already known, which is 5. So substitute r value 5, and cos theta and sin theta can be found in terms of from tan theta. So that can be substituted there. Alright, yes. Now let us find the point. So the point here is of the form r cos theta, r sin theta. So that equals r is 5. 5 multiplied by cos theta. Tan theta is root 2 divided by root 3. So from that we can find cos theta, right, using that right angle triangle. So that means it is root 3 divided by root 5. So cos theta is root 3 divided by root 5. And r again, so sin theta is root 2 divided by root 5. So that is our answer. So that's it. So what is the answer? Root 3, root 15. Alright, so this is root 5 multiplied by root 3, root 15, and root, so this is 10. So that's all. So that is our required answer. This is one of the points which is closest to origin. Alright, so there is also another point, so the negative of that, but we want a point in the first quadrant only. So that means root 15, root 10. That is the point on the curve which is closest to origin. Alright, so that is our required answer. Okay. Match the equations in column 1 with the number of solutions in column 2. Here 3 equations are given. We have to discuss the number of roots of the equation. Alright, so let us take it one by one. So the first one is very simple. See the first equation. So let us take that as f of x. Okay, fx equals, say, x to the power 21 plus 2x to the power 11 plus x to the power 5 minus 2. So this is a polynomial of degree 21. So we have to find the number of real roots of this equation. Alright, yes. Now what do you do? Let us find the derivative. So f dash x, right? So that equals, so 21 x to the power 20 plus 22 x to the power 10 plus 5x to the power 4. Alright, so this is the derivative. Now the derivative have all the powers of x even, right? 20, 10, 4, all the powers are even. So this is the positive value, right? Always, this expression is always positive, right? Because this will never be negative, because x to the power 20, all are even powers, and plus sign here. So this value is always greater than or equal to 0. So the derivative is always positive. So that means this is an increasing function, right? So f of x is an increasing function. So for an increasing function, so what will be the number of roots of the equation? So the number of roots of an increasing function can be at most 1. Alright, so number of real roots, right? At most 1. It can be either 0 or 1. See, an increasing function will intersect x-axis maximum at one point only. Alright, sometimes it may not intersect. So an increasing function, either it will have one root or no roots at all. So this function has, or this equation has roots, either one root or one real root or no real root. Alright, now how will you know whether it has one root or not? So this is an odd degree polynomial. So odd degree polynomial will definitely have one real root, right? Can all the 21 roots be imaginary? So that's not possible, right? Imaginary roots will always occur in pairs. So this 21 roots so cannot be real. All 21 cannot be real. At least one root must be real, and that one root is this, right? So the intersection. So definitely there is one root, and that one root has to be real, right? So one real root. Do you understand? So this equation has only one real root, and the rest of the 20 roots are imaginary. Alright, so that is the first equation. Alright, so now let us consider the second equation. Okay, the second equation is, so let us take that as fx again here, right? X to the power 42. Alright, so plus 2x to the power 20 minus 7x to the power 10 minus 3. Alright, so this is the equation. Now let us try the same method. Okay, see whether if it works. So f dash x equals, so 42 x to the power 41 plus 40 x to the power 10 minus 70 x to the power 9. Alright, so this is the derivative. Now unlike this question, okay, here this value can be negative or positive, right? Do you understand? So the powers are odd, even, so this value can be negative or positive. So this is not an increasing or decreasing function. So this method does not work. So we have to try something else. Okay, so what else can we do here? So f of x equal to this expression. Okay, so how many roots can it have? So we use something called so do you remember this Descartes rule? So we are using Descartes rule. This is one of the methods. See, the first method here is the derivative method. So that doesn't work here. So let us try this method. So what is Descartes rule? So here we have to find the number of sign changes, right? So what are the signs of fx? So f of x has sign positive, right? The first term has a positive sign, plus, minus, minus. Okay, so plus, minus, minus. So we have to find the number of sign changes, right? The first sign is positive and there is no change. And then there is one change. Okay, from here to here there is one sign changes, and next there is no change, right? Minus to minus. So there is one sign change. That means maximum it can have one positive root. So maximum one positive root. So it cannot have more than one positive root. So that is for sure. Maximum it can have one positive root, or it may have no positive root at all, right? Now to find negative roots you have to find f of minus x. What is f of minus x? So this power is anyway even. So this will be the same value, x to the power 42 and plus 2x to the power 20, but this will become positive, right? Sorry, this is also same, right? Minus 7x to the power 10, because again the power is even. So that means there is no change. Again plus, minus, minus. So that means there is only one sign change here also. That means it can have maximum one negative root. But this Descartes rule does not give you the exact number of roots. Alright, maximum it can have one positive root, maximum it can have one negative root. That means maximum this function or this equation can have two real roots. Do you understand? One positive, one negative. Maximum two real roots. Or it can be 0 also. It cannot have one real root. Not possible, because it is an even degree polynomial function. So that means it will have even number of real roots only, not odd number of real roots, because again the same rule, complex numbers, right? Imaginary roots should always be in pairs. So it can have either two positive real or two real roots or no real root. Okay, now how will you know? So whether it has two real roots or zero real roots. Okay, for that we have to use something different. Alright, so here what you do, let us try something like this. See, all these methods are useful while finding the number of real roots of equation. This is one of the methods. So here we use a different method. So let us find f of 0. Okay, what is f of 0? Substitute 0 here. 0 plus minus 3. F of 0 is minus 3. Now let us also find f of, say, something like 1. Okay, f of 1. What is f of 1? 1 plus 2, 3 minus 7, minus 4. Now that is also negative. Okay, no use. So let us find f of something else, right? So f of 10. So let us find f of 10. So what is this? 10 to the power 42. So let us not find the value, but you tell me whether the value is positive or negative. Simply see, 10 to the power 42 and 10 to the power 20 minus whatever it is. So that value is definitely positive, right? 10 to the power 42 is much bigger compared to this value. So that means this value, we don't need to know exact value. We need to know whether it is positive or negative. Positive. So f of 0 is negative. For one value it is negative, and f of 10 is positive. So that means the graph will be something like this. So at 0 it is negative, and at 10 it is a positive value. So at 10 it is a positive value, which means the curve will definitely intersect x-axis at some point between 0 and 10. Okay, we don't know exactly what point, but definitely there will be an intersection, because it is a polynomial expression, it is a continuous function. So definitely there will be a root between 0 and 10. So there is a real root. That means how many real roots are there? There will be two real roots, because one of them is real. You understand? There must be another real root. So one real root not possible here, even degree polynomial. So there will be two real roots. Do you understand? So that implies, so we have two real roots for this equation. So this is the conclusion. So we've used this method, Descartes rule, to narrow down, right? So we've narrowed down that there will be maximum two real roots. but here we have used this method, okay, to check whether it has 0 real roots or 2 real roots. Okay, now we've got the answer, 2 real roots. Okay, and for the next equation, it is already given that that equation has exactly 3 distinct real roots. So let us take the third one. So fx equals, so here x to the power 5 minus 5x to the power 3 plus some k. So this equation has 3 real roots. Alright, now we have to find the possible values of k. Okay, let us find the value of k. Let us try the same method. Let's find the derivative f dash x. So that is 5x to the power 4 minus 15x squared. Alright, so if you take out the common factor 5x squared, so that will become x squared minus 3 equated to 0. Alright, so this can never be, this is not always positive or negative. It is not an increasing function, alright, or a decreasing function. So this has roots. So what are the roots of this equation? So x equals 0, 3 and minus, root 3 and minus root 3. So these are the 3 roots of the derivative. So that means the derivative has 3 real roots. At these points, the function can attain maximum value, minimum value, or the point of inflection. Alright, so the graph may be something like this. Alright, so at 0, root 3 and minus root 3. Okay, but this 0 is the root of this f dash of x. It is a repeated root. Alright, x squared. So that means it is also a root of the derivative of the derivative. Alright, if you find f double dash, right, second derivative, so that will also have root 0, which means it is not only the root of the derivative, it is also the root of the second derivative. That means at the point 0, it has a point of inflection. You understand? Because at 0, it does not change the sign. Okay, it does not change the sign. Less than 0, greater than 0, it has the same sign, because square anyway it is positive. So at 0, there is no sign change, or the second derivative is also 0 at that point. So that means, so this function has the point of inflection at the point 0. So at 0, it has neither maximum nor minimum. Okay, done. Which means at one of these points it should be minimum, the other point it must be maximum. You understand? So it is an odd degree polynomial. It will end at infinity, right? It will reach infinity, and also the positive coefficient, that means it will be here like this. And at the point 0, it is not minimum or maximum, so that means it will be like this. You understand? So this is convex and it will change to concave. You understand? So that is the point of inflection. So done. Now at the point minus root 3, so that will have the maximum value. Okay, at one point it is maximum, one point minimum. Okay, suppose this is the graph of the function. Now how many real roots does it have? So it has only one real root, right? So this function intersects the curve x-axis at only one point. That means only one real root. So that means, so this will have 3 real roots only when the graph is like this. You understand? The graph should be like this. So only then it will have 3 real roots. Okay, now what is the condition? This at root 3 the value is negative. Okay, at minus root 3 the value is positive. So f of root 3 should be negative, f of minus root 3 should be positive. But if f of root 3 and f of minus root 3 both are positive, then it will have only one real root. So one of them is negative. At root 3 it is negative, at minus root 3 it is positive, or generally they will have opposite sign. So f of root 3 and f of minus root 3, so this product is negative. Only then it will have 3 real roots. Okay, so that's what, find f of root 3. So just substitute root 3 there. So you will get, so root 3 to the power 5. Alright, so that is same as say 9 root 3 minus, so 5 multiplied by, so root 3 cube, so that is 3 root 3, so minus 15 root 3 plus k. So that is f of root 3 multiplied by f of minus root 3 is minus 9 root 3 plus 15 root 3 plus k. So this value should be negative. So we get k minus 6 root 3 and k plus 6 root 3. So this product is negative. So that's all. So that is the value of k. So k lies between minus 6 root 3 and 6 root 3. So this is the value of k. You understand? So we can say that, so what is the maximum possible value? Or you can take, say, k square is less than, so 36 multiplied by 108. So what are the possible values of k? The maximum value, integer value that k can take is 10, right? 10 squared is 100. Okay, now 11 squared is 121, so that exceeds this 108. So that means k can be maximum 10. So the integer value of k, maximum 10, similarly minimum minus 10. So how many values can k take? The integer value. So k can take 21 value, okay, 21 integer values. Alright, so from minus 10 to plus 10, so we have 21 integer values, so that is the answer. So k can have 21 integer values. Do you understand? So that is one of the answers. So this method is very important, especially when you have a cubic equation. Mostly this method is used for a cubic equation, right? So when you have a cubic equation, we want to find the number of real roots of the cubic equation. So this is what we do. You find the derivative and find the roots. If the derivative does not have roots, then the function is either increasing or decreasing. In that case, only one real root, so no problem. But the derivative has a root, okay, has some roots, right? So at these roots, so the function should have opposite values. At one value it is negative, the other value it should be positive. Do you understand? So this is the standard method used especially for the cubic equation, but it can also be used for the fifth degree equation for this particular case. Do you understand? So the answer to the question here is this one. 21 is the value of k, okay, the maximum, the number of values of k. Do you understand? So that is the answer. The least value of alpha for which 4 alpha x squared plus 1 by x greater than equal to 1 for all x greater than 0 is. Here some inequality is given, we have to find the value of this alpha, the least value of this alpha, right? So what is given here is 4 alpha x square plus 1 by x. So that must be greater than or equal to 1. So here x is positive. See, so this inequality, so that means this expression should have minimum value 1, right? So the minimum value of this is 1. To find the minimum or maximum value, usually what you do, you find the derivative of the function equated to 0, we know the method. But for a change, we will not do derivative method, we will use the arithmetic mean, geometric mean method. Because this is x square, x, they are like reciprocals of each other. So we will not find directly the arithmetic mean, geometric mean. So we will first write this 1 by x as 1 by 2x. Plus 1 by 2x. Okay, yes, why? Then only if you find a geometric mean, take the product, that x will get cancelled. Okay, so you write 1 by 2x plus 1 by 2x, so that is same as 1 by x. Alright, now we have the formula, the arithmetic mean greater than or equal to geometric mean, as x is greater than 0. So no problem, we can use the arithmetic mean greater than equal to geometric mean idea. So arithmetic mean of 3 numbers a plus b plus c divided by 3 is greater than or equal to cube root of a, b, c. So this is the relation between a m, g m for 3 numbers. So let us use this relation. It is like this one, a plus b plus c. So a plus b plus c is greater than or equal to, so this whole value is greater than or equal to 3 times the cube root of the product a, b, c. So let us multiply. So 4 alpha x square multiplied by 1 by 2x multiplied by 1 by 2x. Okay, so this is greater than or equal to 3 multiplied by, so this x square gets cancelled. Alright, x square here gets cancelled, 2 is also cancelled, so this is cube root of alpha. So this is the inequality we have got. So this value, the given expression is always greater than or equal to 3 multiplied by cube root of alpha. But it is already given that this value is greater than or equal to 1. So that means, that implies this 3 multiplied by cube root of alpha must be greater than or equal to this value 1, right? So only then this inequality will be satisfied for all values of x. So let us simplify this. So what do you get? So cubing this will get alpha greater than or equal to cube of this. So 1 divided by 27. So that's also, this is the relation satisfied by alpha. Alpha should have minimum value 1 by 27. So that's all. So that is the answer. The least value of alpha is 1 by 27. Okay. The equation x log x equal to modulus of 2x minus a has at least 2 solutions. B is the maximum value of a. Then the range of the function f of x equal to log of modulus of log x by x, where x belongs to the interval 1 by b, b square is. This question is similar to the one which we have done already. We are given an equation with the parameter a. This equation has at least 2 solutions. We have to find the possible values of a, right? So the equation given here is this one, x log x equals modulus of 2x minus a. Like we did already, we have to consider these two as 2 separate functions. Y equal to x log x. So that is one function, and the other function y equal to modulus of 2x minus a, right? So these two are equal here. So that means, so we have to draw the curve, and you have to draw the curve of this function. Then the number of intersections is the number of solutions. Do you understand? So let us draw this x log x. As x tends to infinity, this tends to infinity. and when x is 1, so this is 0, so log 1 is 0, and when x tends to 0, x cannot be 0, as x tends to 0, so this value will become 0, right? That is a limit question. So x log x tends to 0 as x tends to 0. So this is roughly the graph of this function. Okay, so we have drawn this x log x. Okay, let us draw this. Now this depends on the value of a, right? Now first let us draw modulus of x. This is modulus of 2x. Now how many solutions does it have? So these two curves intersect at only one point, right? If we extend that curve, this will intersect at only one point. So only one solution, but we want two solutions. Now if you change the values of a, right? If you increase the value of a, so this curve will move to the right, right? It is shifted. So now it will move to the right. Now how many solutions are there now? Now here also we have only one solution, right? Only one intersection. So now we want two solutions. So that will happen only when these two curves touch each other like this. So this is where we have only two solutions, right? Exactly two solutions. Now let us find the condition. Let us use the condition that these two curves touch each other at a point. Okay, when the two curves touch each other at a point, so there will be a common tangent. That means the derivative of this function and derivative of that function, they are equal at that point. Alright, let us find the derivative. So dy by dx. So that equals, let's find the derivative, x multiplied by 1 by x. So that is 1 plus log x. So that is the derivative of this function. So that must be equal to the derivative of this function. To find the derivative, I am just considering 2x minus a, no modulus, because for that branch, so the value is positive, right? 2x, that is the positive part. So 2x minus a is already positive. So that means you need not use the modulus. 2x minus a has derivative just 2. So then the value of log x is 1. So we get the value of e, which is, sorry, the value of x is e. Okay, so we got the value of x. That means the point where the two curves touch each other, so that point the x coordinate is e. Let us find the y value. So substitute this value of e here in this equation or here, right? Because both the values are same. Let us substitute here. So e log e. And that should also be equal to the value of y here, because that is a common point. So again, I am not using the modulus. 2 times x minus a, so there we substitute this e. So that is 2e minus a. So simplify this. So log e is 1. So we get the value of a. So that is e. So this is the maximum possible value of a. If we increase the value of a further, so there will be no intersection. I mean only one intersection, right? Not two. So this is the maximum value of a. So the value of b, which is the maximum value of a, so that is this e. So we got the value of b. Now some interval is given. So the interval is given. So that is, so 1 by b to b square. So what is the interval 1 by b to b square? So that is 1 by e to e square. In this interval, we have to find the maximum or minimum value of another function, right? Log of log x divided by x, right? So in this interval, okay, so let us find it. Now let us take that function f of x, that is log of modulus of log x divided by x. Okay, so to find the range, that means the maximum or minimum value of the function, we have to take the derivative. We have to find the derivative, equate that to 0. That is the usual method. But this function is already very complicated, so let us not find the derivative. So I will only consider this function. Okay, let us find the range of this function. Later on we can take log. So consider that function only as some other function g of x, which is log x divided by x. Okay, so to find the maximum or minimum value of this function, so we will find the derivative, which is g dash x, that is x square, x multiplied by 1 by x, so that is 1 minus log x. So equate that to 0, we will get the value of x, so that is e. So e is the value at which the function may be maximum or minimum. Okay, we don't know. So to check whether it is actually maximum or minimum, so we have to use the second derivative and all that. But we are not going to use any of these methods, because we only need the maximum minimum value in an interval, in a closed interval. To find the maximum or minimum value in a closed interval, we just have to substitute this value in the given expression. Okay, and then we also have to substitute these end values. Among these, whichever is the maximum value, that is the maximum value of the function. Similarly, the minimum value. So let us find all these values. So let us find, so g of, say, e. So g of e. So that is log e, which is 1 divided by e. Similarly, you find this end value. So g of 1 by e. So that is, so here you substitute log of 1 by e, that is minus 1 divided by 1 by e. So that is minus e. Similarly, the other end point, which is e square. g of e squared. So here log of e squared, which is 2, so 2 divided by e squared. So g of x has minimum value minus e. This is the minimum value among these three. So the minimum value is this. And what is the maximum value? So that is 1 by e only. So that is the maximum value. So maximum value is this. So this is the maximum value because this is smaller than this, right? So 1 by e is the maximum value and this is the minimum value. So that means the range of g of x. So g of x belongs to the interval minus e to 1 by e. So that is the range of g of x. But that means the range of log x divided by x. But we want modulus of that. So modulus of g of x lies in the interval. Modulus of g of x belongs to the interval. So what is the interval in which modulus? See, this is from minus e to 1 by e. Modulus of that lies in what interval? It has to be positive only. So the minimum, it has to be 0, but it cannot be 0 also because we are finding log. So open interval 0 to what is the maximum value? See, it is like this. 0 here, minus e here, and then 1 by e here. Okay, so this is the range of this g of x. But you take the modulus. When you take modulus, the negative value will become positive. So minus e is this side. So minus e will become plus e. So that means that will be the range 0 to plus e. You understand? See, when you take modulus, all the negative values will become positive. So instead of 0 to minus e, it will become 0 to plus e. So that means the range here is 0 to e. So that is the range of modulus of g of x. You understand? So modulus of g of x. Now again we need a log, right? Log of this value, log of modulus of g of x. So log of modulus of g of x. That belongs to the interval. Log of 0, that tends to minus infinity, right? And log of this e is 1, okay? So that's all. So that is the range of our required function, log of modulus of g of x, that is this function. Do you understand? So that is our required answer, minus infinity to 1. So that is the range of the given function in that interval. To find the interval, we did this, right? So this question and that question are not at all related. Just to find the value of this b, we have to do all this, right? We found the value of b, that is the interval. In that interval, we found the maximum or minimum value of that function, right? So these two are entirely different questions, right? So we find the value of the range of the function. So that happens to be this one, minus infinity to 1, okay? Okay, enough for the day. I'm thinking of doing some questions from the past JEE advanced papers in the next class. So bye for now.